Hello friends, how are you all? I hope everybody is doing great, doing good. Okay, so the main agenda of this video is to discuss about percentages. Yes, the very famous topic in arithmetic and easily understandable because it is definitely comfortably connected with real life. We see the percentage everywhere around us in our day-to-day lives. Okay, and the moment I say arithmetic, so I hope you know the syllabus of arithmetic is nothing but percentages and its applications, that is SICI and simple interest, compound interest, profit loss discount. Second pillar is the ratios and its applications, that is ratio, proportion, variation, partnership, averages, mixtures and allegations. Okay, and third pillar is time, speed, distance, and time and work. So this is the broad range of arithmetic, one of the most important topics in every MBA entrance examination, and not just MBA entrance examinations. You take any other entrance examination wherever the aptitude tests are involved. These are the key topics. Comfort is there in terms of syllabus because, and also in terms of concept, because it is nothing but you have done this actually in 8th, 9th, and 10th standard. So that is why it is even more special. Okay. So in today's video, I'm going to start with the first topic, that is percentages. Yeah, so stay tuned till the end. You'll learn definitely. Okay. All right. All right. So percentage, percent. Actually, if I say, when did you hear about this word for the first time in your life? Yes, it's mainly about our marks in terms of our academic scores and all performances. That is a common answer which everybody will give you, right, friends? Yeah. So if somebody asks you your score, and if you tell them I got 479 out of 550, they become very uncomfortable. They will only tell you, "Beta, please tell me how much percentage is that? How much you scored in terms of percentage?" So you tell them, yes, I scored, let's say 92%. So they understand it easily. So what is the main reason of giving this example? So just to make you understand, aware that this is the beauty of percentage, that is, if there are any complicated values in comparison, you are converting the same set of numbers into out of 100. That is an easier way to communicate. So this is the convenience which is offered by the percentages. That is why they are very famous throughout. Okay. All right, cool, let's go ahead. Per means out of, cent is 100, so out of 100, so it's a fraction whose denominator is 100. All right. So these are the various topics. First is some fractions whose percentage equivalent we should know, because they are going to be used quite extensively in the entire syllabus. Yeah. See, percentages is not just important for quant section or math section. You know very well there is one more section, DILR. So in data interpretation, majority of the questions based on calculations involve this logic, this concept of percentage. So from that point of view also, it is very, very important. Okay. So stay tuned. Let's learn. All right, friends. Please keep your notebook pen ready. Keep taking the notes properly. Your entire lecture notes should be there properly so that you can revise it at any point of time quickly. Cool. So half is into 50%. See, some I have developed some tricks to remember these reciprocals. Okay, one way is by heart straight away. Otherwise, second way is, so half is 50%. Now just keep doing half. Half of half, 25%. That is 1 by 4. Half of this again, 1 by 8. That is 12.5%. One more time half, 1 by 16, 6.25%. So in this way, we can remember these easily, and you can derive it at any point of time if you know this logic that keep doing half. All right. Next, 1 by 3, everybody knows is very famous, 33.33%, friends. Yes, half of this, 16.66 or 16.67. Half of this again, 1 by 12, that is 8.33%. Again, the logic was simple, keep doing half. Okay. And then 1 by 30 is very easy, 1/10 of 1 by 3. Just shift the decimal to the left by one place, so 3.33%. Comfortable? Okay. 1 by 5, very easy start, 20%. Half of 1 by 5, kind of an insult to your talent. Yeah. So 1 by 10, that is 10%. Now one third of 1 by 5. Yes, 1 by 15. All sixes. Yuvraj Singh, remember 6 balls, 6 sixes, India versus England? Yeah. All the cricket fans must be knowing this. So 1 by 15, Yuvraj Singh, 6.6666%. Yeah. All right. Next is 1 by 7. Now, how do I remember this? 7 twos are 14 and then 14 twos are 28. So double two times. So 1 by 7 is 14.28%. Okay. Half of this, yes, 7.14%. Simple, comfortable. So 1 by 14 is 7.14%. One more time half, friends. So 3.57%. That is nothing but 1 by 28. Also, if you see carefully, you see three consecutive odd numbers, isn't it? Correct. Three consecutive odd numbers. Cool. Got it? All right. Do you remember 9/11 US attack? The one of the biggest incidences in US history. 9/11. We all know very well. So let's just take advantage of that number 9/11. So 1 by 9, 11.11. 1 by 11, 9.09. So 9/11. If 9 is there, think of 11. If 11 is there, think of 9. So 1 by 9, 11.11. 1 by 11, 9.09%. Cool. Next is 1 by 13, which is 7.7%. Generally, 13 is considered to be unlucky number. Similarly, we have a lucky number that is 7. So this statement goes for life. If you're trying for something, not getting success, don't give up. Because if you're once unlucky, you'll be lucky twice. Keep trying. Okay, so once unlucky, twice lucky. All right. Next set of fractions. Now see, 1 by 18, dedicated to all the smokers. The numerical brand of cigarette, 555. Yeah. So 1 by 18, smoking brand, 555. That is 5.55%. I'm sure you won't forget this. Now, how I derive other two? Just check. So 1 by 17, retain the first 5, change the last two 5s. And change by what? See, in 17, if you add the digits, so 1 plus 7 is 8. So 5.55 became 5.88. Similarly, next is 1 by 22. So now retain the last two 5s. Change the first 5. Change by what? So 22, sum of the digits is 2 plus 2. That is 4. So 4.55. So if you remember 1 by 18, from this you can easily link or derive 1 by 17 and 1 by 22. And remembering 1 by 18 is absolutely comfortable. Easy, right? 555, cigarette brand. Hello, I'm not promoting any cigarette. Please, it's just for remembering. Thank you. Next is 1 by 20. Very, very easy. 5%, 25 is 100, 5%. Now 1 by 19. 5 square is 25. So add 0.25 and for 1 by 21, subtract 0.25. So it becomes, so 1 by 19 is 5.25. 1 by 21 is 4.75. Easy? Yeah. Similarly, there is one more group on the similar lines. 1 by 25. Very comfortable, 4%, right? So 1 by 25 is 4%. While going up, you'll add. While coming down, you'll subtract what? 4 square is 16.16, or you can round it up to 0.15. So actually, you can add 0.16. So 1 by 24 becomes 4.16, and 1 by 26 will become 3.84. Doesn't matter that much. So you can follow the same trend. Square, 4 square 16. So add 0.16, subtract 0.16. So 4.15 or 4.16 both are fine. 3.85 or 3.84 both are fine. Okay. All right, let's go ahead. 1 by 23, 4.35, under 29, 3.45. Now 23 and 29 are two consecutive prime numbers. So for 29, remember like this, just count 3 numbers consecutively from 3 onwards. So 3, 5, 7. That was consecutive odd. But I'm telling you to count consecutive numbers. So 3, 4, 5. 3, 4, 5. So 1 by 29 is 3, 4, 5. And for 23, just flip or swap the first 2 digits. So 3, 4, 5 becomes 4, 3, 5. So 29, 1 by 29 is 3, 4, 5. 1 by 23 is 4, 3, 5. All right. Cool. Okay. For 27, I couldn't find any technique. Just say that 27 is 37. So 1 by 27, 3.7%. Similarly, what would be 1 by 37? Yes, 2.7%. Remember, Now, a few more set of fractions I'll pick up from these and derive few more. See, 1 by 12.5%. Remember 1 by 2 ka half ka half. Now we're going to do odd multiples of these 1 by 8. Even multiple will be very easy, right? 1 by 8 into 2 is very comfortable. 1 by 4, that is 25%. Let's do odd multiplication. 1 by 8 into 3. So 12.5 into 3, which is ultimately 37.5%. All right. Similarly, 1 by 8 into 5, 62.5%. So 12.5 fives are. You won't believe these fractions. This remembering these percentages is going to be so helpful to you all. Please stay focused. Yeah. 12.5 sevens are. So 12 sevens are 84, 0.5 sevens are 3.5. So 84 plus 3.5, 87.5. These were multiples of 1 by 8. All right. Cool. Next is 1 by 9, 11.11. This is going to be gift. So 2 by 9. Very, very comfortable table of 11, 22.22%. Yes, 5 by 9, 11 fives are 55.55, 8 by 9, 88.88%, and so on. It's just a table of 11. Cool. Similarly, 1 by 11, 9.09. So for multiples of 1 by 11, now we will be dealing with table of, yes, 9. 3 by 11, 27.27, 6 by 11, 54.54, 7 by 11, 9 sevens are 63, so 63.63%, and so on. Comfortable? So 1 by 8, 1 by 9, 1 by 11. Yeah, these three sorted. Okay. Next is, remember this magical sequence 142857. See, 1428, we know already 1 by 7. Check. So start from 1, so 14.28. 2 by 7. 2 by 7 if I want. Remember base as 14. 14 twos are 28. So 28 starts from which digit? 2, na? So you will start from 2 in this sequence. So you will start from 2 and take 4 digits. So 28.57. So 2 by 7 is 28.57. I repeat once again. So base was 14, double 28. Start from 2. So start from 2, 28.57%. All right. Getting it? Okay. So similarly, can you predict 3 by 7? Yes, 14 threes are 42. So start from 4. So 42.85%. This is your 3 by 7. Come on, similarly 4 by 7. Right? 5 से शुरू होगा 57.14%. चलो quickly 5 by 7, 14 5s are 70. So 7 से start होगा. So 5 by 7, 71.42%. Similarly 6 by 7, 46 are 84. We'll start from 8. So 85.71%. Okay, got it. So these are the must-know fractions for a stronger calculations in entire mathematics or quant and DI, data interpretation. Okay, all right. Then one simple logical rule to remember: x% of y and y% of x. What do you feel, friends? What's the relation between them? Correct. Just see. If I write x% of y, it will be this. Y% of x will be this. And there is product sign, na? X into y by 100, y into x by 100. So ultimately in product, the order doesn't matter. So both are equal. Okay. So if I say 20% of 30 is same as 30% of 20. Yeah. So for example, when should I think of this? Suppose if I want 84% of 25. So our focus is 84%. For the standard fraction, but instead of 84%, if I switch my focus to 25%, so 84% of 25 is same as 25% of 84. Now 25% is 1/4. So 1/4 of 84, 21. Okay, cool. Got it? Yes. In such scenarios, you should think of this simple logical approach. All right. Now let's come to the main concept. The first concept, which is the most important. If you understand this, majority of the things will be sorted. How do we handle percentage increase and decrease? Let's see. Look at these examples. A is 25% taller. Sales of the company decreased by 15%. X scored 30% and Y scored 20%. What do you feel? Is this information complete? No, right? I hope you felt that there is something missing. Yes, all of these are now complete. Than B compared to last year. Over last year than the expectation. X scored 30% out of 50 in section 1. Y scored 20% out of 200 of the total. What does this indicate? Base. So in percentage, the base is very, very important. Very important. All right. So you need to know the base before proper comparison. Let's go ahead. Let's see a few more examples to understand this. So A is 25% taller than B. Yeah, what do you feel? In this language, of course, the base is B, right? Than B. A is compared with B. So we'll take B as the base. Yeah. First method of representing these A and B in terms of numbers is method of base 100. This is what we have been learning right from our school days. Correct? So if I take B as 100, A is 25 more. If B is 100, A is, see, 25% of 100 is 25. So if B is 100, A is 25 more than 100. So A is 125. Isn't it? Comfortable? Yeah? Got it? So base 100 was comfortable, right, friends? You can also look at it as in terms of multiplying factor. If I take B as whatever number, so A is 1.25 times B. So whatever B is that plus 25% of B, right? So B plus 25 by 100 into B, if you write that, B plus 0.25 into B, B common, 1 plus 0.25, so 1.25 times. So 25% higher can also be called as 1.25 times. Understand other side of the same language. One more variation, one more variety. So if somebody says a value is 25% higher than the other value, it simply means that value is 1.25 times the other value. 30% higher means 1.3 times. 68% higher means 1.68 times, and so on. Okay, cool. What about this example? A is 5.88% taller than B. So B is the base, right? B is the base. So if you take B as 100, A is 5.88 above. So 105.88. So in this, if you take 100 as B, so you know, na, A will be 5.088, sorry, 5.88 more. So 105.88. What do you feel for this kind of number? 105.8. Yes, friends. Very, very tedious. It will increase your pain of calculation a lot. Yeah. So relying on the base 100 every time is not a good way at all. Okay. Yeah. Similarly, multiplying factor, you know now, 1.0588 times. Oh my God, even worse. Yes. So for such situations, we are coming with a very nice logic, the fraction method. Yeah. The funda is first get the fraction. 5.88%, if you remember our secret group, 1 by 17, 18, and 22. Remember, 5.88% is 1 by 17. Then how do we develop further? So A is 1 by 17 more than B, means 1 plus base fraction is the logic. Yeah. So whatever B is that plus 1/17 of B more. Okay. Yeah. So say I'll tell you. I was not able to write on that PPT, but yes, sorry. So A is 5.88% taller than B, right? So A is whatever the B is plus 5.88% of that B, isn't it, friends? So B plus 5.88% when reduced as a fraction is 1 by 17 of B means into B. So B common. So 1 plus 1 by 17. Okay, 1 plus 1 by 17. So ultimately b into 18 by 17. So this format only we are calling it as 1 plus base fraction. So that 1 by 17 we are terming it as base fraction, friends. And 1 plus base fraction will be your final fraction. And if there's a decrease, of course, so 1 minus base fraction. All right. This is the thought. That is why that 1 came into picture. I hope you now know. You might be wondering how come that 1 is there. This is the funda. Okay, friends. You got it? All right. I hope you understood now. So how come that 1 plus base fraction is there? That logic. So base fraction 1 by 17. So 1 plus 1 by 17, 18 by 17. Yeah. So A is 18 by 17 times B. So basically that 1.0588. That is the decimal version of this fraction. You can check in your calculators. But the more comfortable one is 18 by 17. So all this is developed keeping in the mind that CATS is not allowed. You need to do all these calculations comfortably. Yeah, this is a simple planning so that we can manage our calculations very well. So pain of calculation should not be there. But that is the whole agenda. Okay. And the last one again is also very, very nice method. Logical way of thinking, method of parts. 1 by 17, you just break it up. Let the base be 17. So if B's height is like 17 parts, 17 units, whatever it is, A's height is 1 part more. So how did I get that 1? That numerator was 1, right? So base was 17. So 1 by 17 more means what? On every 17 parts, 1 part more. So if B is like 17 parts, A will be 18 parts. If B is 34 parts, A will be 2 parts more. Yeah, 2 by 34. No? So A will be 36 and like that. So in the most reduced form, if B is 17 parts, A is 1 part more. So A is 18 parts. That way also, this is lovely logic. So yeah, so B is 17 parts worth of height and A's height is 1 part more. So A's height is 18 parts. All right. These are the 4 simple logics. Mainly third and fourth method are the best ones to deal with. Okay. All right. Comfortable. Cool. Let's go ahead. Concept of percentage change. Look at this statement. N has 3.45% less money than M. So in this statement, who is the base? Of course, M. Than M, right? And fraction for 3.45, remember 23, 29? 29, 3, 4, 5, 3 consecutive numbers, 3, 4, 5. So 1 by 29 is 3.45%. So I should take M as 29. So N has 1 part less. So if M has 29 parts of money, N has 1 part less. Yeah, or else method of fraction 1 minus base fraction, right? So 1 minus 1 by 29, which gives us 28 by 29. So N has 28 by 29 times M. Correct? This is how we will relate them. Okay. That statement will be written like this in mathematical form, that N is equal to 28 by 29 times M. All right. Okay. Method of parts, simple. If M has 29 parts of money, N has 1 part less. So N has 28 parts. All right. Cool. Got it. Okay. Similarly, this one, A is 25% taller than B. Then see the next line. By what percentage is B shorter than A? Can you just see the language here properly? Earlier the base was B, and in the new statement base is A. So we also call it change of base logic. This is change of base. So we can fix B as 4, right? 1 by 4, denominator is 4, B as 4. So if B's height is 4 parts, A's height is 1 part more. So A's height is 5 parts. Correct? Okay. Cool. So in the next statement, by what percentage is B shorter than A? Now A is the base and A's value is 5. So A is 5. So now we are comparing with 5. So B is 4, A is 5. Hello. B is 4, A is 5. So B is 1 less than 5, right? So 1 on 5. Just understand the base. Earlier the base was 4, new base is 5. That's it. So change of base. So 1 by 5, which is ultimately 20%. Got it? So by what percentage is B shorter than A? 20%. Please don't think like that, that A is 25% more than B, so B is 25% shorter than A. No, no, no. This is percentage here. Base is important, as we had seen initially. If they would have said, friends, that A is 25 centimeter taller than B, here I'm giving you exact actual value that A is 25 centimeters taller than B. So of course, B is 25 centimeter shorter than A. Then it will be the same answer because it is absolute value, actual value. But here, as of now, it is just a relation, right? Percentage, which works on the fundamentals of ratio. That is nothing but developing through base. Okay, one more example. X scores 4.75% less than Y. So Y is the base. 4.75. Remember that group? Yeah, 19, 20, 21. Yes. So 1 by 21 is 4.75%. So come on, quickly. Yes. So Y scores 21 parts. So X scores 1 part less. That is 20 parts. Correct? So by what percentage has Y scored more than X? So Y than X. So new base is X. So X is 20. Y is 21. Yeah. So Y has scored 1 more than that 20, right? So 1 on 20. So 5%. Simple, easy, understood? All right. So quickly think about this. Okay, you can pause the video, you can think. Yeah. All right, friends, you must have thought about this. 10% is 1 by 10, then B. So B is the base. So if B is 10, A is 11. Yeah. B is 10, A is 11. In the new statement, then A. So A is the base. So A is 11, so B is 10. So B is 1 less than 11. So 1 by 11, 9.09%. 9/11 US attack, right? Okay. One more. Yeah, you can pause the video and you can think. All right, friends. I'm sure you must have got it till now. 20% is 1 by 5. B is the base. So B is 5. A is 1 less. So A is 4. Correct? Yeah, just switch it now. Then A. So now A is the base, which is 4, and B is 5. So B is 1 more than 4. So 1 by 4, 25%. Understood? All right, friends. Next logic is offsetting. Offset change. What does this mean? Percentage by which a changed value should be increased or decreased to bring it back to original value. So what is the most important part here? To bring it back to original value. For example, 20% increase can be offset by 16.67 decrease. How? So 20% as a fraction is 1 by 5. How will you start? 20% as a fraction is 1 by 5. Means if old value was 5, so there was a growth of 1. So it became 6. So 5 became 6. So logically, now 6 should become 5. Isn't it? 6 should become 5. So 6 should reduce by 1. So 1 on 6 and 1 by 6 is 16.66%. Okay. Yeah. Understood? Okay. Next is 6.66% decrease. Now 6.66% is 1 by 15 decrease. How will you convert this? Old value was 15, 1 part less. So new value is 14. 15 became 14. So now 14 should become 15 to offset the change, right? Bring back to the old value. So 14 should become 15. So 1 increase on 14. So 1 by 14, hence 7.14%. Correct? One more way to look at it is 20% increase. So 1 plus base fraction. So means value became 6 by 5 times. So to get the old value back, I should nullify this change. So multiply it by 5 by 6. Then it will be into 1. Means no change. Any number into 1 means same number. And 5 by 6 means what? 1 minus 1 by 6. Yeah. And 1 by 6 means 16.66%. So 1 minus. So that is a decrease. Similarly, 6.66% decrease means 1 minus 1 by 15. So 14 by 15. So to nullify it, we need to multiply 15 by 14. 15 by 14 means 1 plus 1 by 14. 1 plus means increase by how much? 1 by 14. 1 by 14 is 7.14%. Understood? Yeah. Okay. Now, one more way to put that same thing is like this. Suppose price of the petrol, let's say, increased by 20%. So due to widespread opposition, government had to bring it back to old value. So by what percent the new price should be brought down by to get the old value back? So let's see this. Same thing. So 20% is 1 by 5. So how will you start? Old price is 5. It increased by 1. So it became 6. So old was 5. New is 6. So now 6 should become 5. So 1 less. So 1 on 6. Yes, 16.66%. Same thing, yeah. Now understood? Okay. One more way to put it in this manner. Suppose price of tomatoes increased by 20%. So by what percent the consumption should be brought down so that the expenditure remains same, the budget does not change. Yeah. So how do we write this relation? So price, consumption, and expenditure. 3 words. You know how to relate them, right? Price into consumption is expenditure. Yeah. Price increased by 20%. Now 20% is 1 by 5. Yeah. So base is 5. So if the old price was like 5 parts, 5 rupees you can say. So new price is 1 part more. The new price is 6. Now see how I adjust consumption to have the same expenditure. I'll just flip these two values only. Let the old consumption be 6. So new consumption is 5. Can you see? 5 into 6, 6 into 5. Product remained same. That is what we wanted. Now expenditure should not change. So now you can compare consumption. Old consumption was 6. New consumption is 5. So 1 less, right? 1 less than 6. So 1 by 6, 16.67%. Okay. All right. Understood. Cool. One more concept, the last one. Okay, friends. So last topic is about successive percentage change. Let's understand this. A scores 10% more than B. I hope the base and everything is very clear now. B scores 20% more than C. Now we are comparing A with C. By what percentage did A score more than C? All right. Since the numbers are very comfortable, so we can easily afford to develop this relation by using base 100. So how will you start? Yes, ideally you should start with C, right? If C scores 100, B scores 20% over and above 100. So 120. First line was A scores 10% more than B. So if B is 120, now more than B, so B is the base. So you need to find 10% of 120, not of 100. Huh? So 10% of 120 is how much? 12. Isn't it? 1/10. So 12, right? So A scores 12 more than B. So ultimately A scores 132. So now if you compare with C, it was 100, A is 132. So now the relation is, yes, 32% over and above. 32%. I feel some of you might be expecting 10 plus 20, 30 now. So how come it became 32? Right there in front of you. Simple logic is that 10% was not on 100, it was on 120 on the new base. There was a consecutive change, successive change. Yeah. Let's understand this through a diagrammatic manner. So whatever the C is, this blue part. So B is 20% extra. So that C plus 20% of C. So this is this full blue plus red is B, right? Now A is 10% more. So logically that blue portion will also increase by 10% and this red portion will also increase by 10%. So blue portion was 10% more than C, extra increase, and this red increased something. So this is extra, right? 10% of 20% of C. This is exactly 2%, right? Yeah. 10% of 20% of C. Right? So 10% of 20 is 2, 2 by 100. So 2% of C. That is how you're getting that extra increase. So 10% plus 20%. Right, friends? Extra is 10% plus 20% plus 10% of 20%, which is ultimately written like this. We're developing a format, a formula slowly. So this is 32%. Okay. One more example. Price of the vegetables increases by 10%, while the monthly consumption also increases by 30%. Price and consumption. So find the percentage increase in monthly expenses. Super. Base 100. You know this relation already. Price into consumption is expenditure. Suppose price was 10%, 1 by 10, 30%, 3 by 10. Both of them had the same base, not 10. So we can assume the old price is 10, consumption is 10, so expenditure is 100. Okay, so consumption was 10 kgs, price was 10 rupees per kg, so total expenditure is 100. Let's develop. Price increased by 10%. So 10% of 10 is 1, right? So new price became 11. Consumption increased by 30%. So new consumption is 13, isn't it? 3 more. 30% of 10 is 3. So new consumption is 13. So now new expenditure is what? 11 into 13, 143. So you can see the change now. 43% over and above. Yes. Let's understand this again through the diagrammatic manner. So price into consumption is expenditure. So this is exactly like area of a rectangle, wherein I'm taking length as consumption and the breadth as the price. Okay. So area is this expenditure part. Now, price increased by 10%. So see, this is going up by 10% amount of that old price. Consumption increased by 30%. Okay, now that top right corner, don't you feel it is like increase this blue portion by 30% to match it, or this red portion should go above by 10% to match it and complete the rectangle? Yes, so overall increase now if you see that blue portion plus red and blue together. So 10% plus 30% plus 10% of 30%, right? Perfect. So A% increase followed by a B% increase is equal to net increase of A plus B plus AB by 100. This becomes the formula for successive percentage change. Okay, friends. And if there's a decrease, just take minus sign. For example, if I have, let's say, 30% increase followed by 20% decrease. So what will be the net change? A is 30 and B will be taken as minus 20. A plus B plus AB over 100, the whole percent. 30 minus 20, 10, and minus 600 upon 100, so minus 6. Means net, there is an increase of 4%. All right. And if these values are not comfortable, we can always go by fraction logic. 1 plus base fraction, 1 minus base fraction. All right. Got it? Correct? Cool. So I hope you understood whatever we discussed today in this percentage video. Initial reciprocals, important ones. Then we studied the logic of percentage increase, decrease, in which we saw those 4 varieties. You should understand especially the fraction logic and the method of parts. Then percentage change logic, and in that we also studied offsetting the change, nullifying the change, and finally successive percentage change. So with this much, we can face any question based on percentage. And if this is very, very strong, you will have no tension or problem in learning simple interest, compound interest, profit loss discount. All right, these are directly connected to this topic. So stay tuned. Please make a proper note, revise this, listen to this again and again till the time you don't understand. Okay. Thank you. Take care. All the best. Bye-bye.